Now we continue our lesson with implicit differentiation. The learning outcomes of this lesson is to differentiate the implicit function. Before that, we want to know what is implicit function. So far, we have differentiated a function in the form of y is equal to fx, or explicit function, whereby the y appears alone on one side of the equation. Some example of explicit function we have discussed before, such as y is equal to x squared, y is equal to ln x, y is equal to x cubic plus sine 3x, and y is equal to e powers of cos 2x. We can see that y appears alone on one side of the equation. However, sometimes the functions are defined by equation in which y is not alone in one side of the equation or not in the single form of y. Some examples of that, such as x squared plus y squared is equal to 9, sin y plus xy squared is equal to ln x, y cubic is equal to x cubic plus y sin 3x, cos y is equal to e powers of cos 2x, and others. These kinds of functions are called as implicit function. The method for obtaining the derivative of implicit function is called implicit differentiation. The procedure for implicit differentiation consists of 4 steps, which are: the first step, we need to differentiate both sides of the equation and treat y differentiable function of x. It means that when we differentiate y, we have to multiply it by dy dx. Step 2, we need to collect the term of dy dx at one side of the equation. Step 3, we factor out the dy dx. And lastly, in step 4, we are going to solve the dy dx. Now we want to find the dy dx for implicit function x cubic plus y squared minus 4x is equal to sin y. We will use the procedure for implicit differentiation. Step 1. We have to differentiate both sides of the equation. If we differentiate x cubic, we will get 3x squared. If we differentiate y squared, we will get 2y dy dx. Remember, when we differentiate function in terms of y, we need to multiply with dy dx. Step 2, and before that, we differentiate for x, we get 4. We differentiate sin x, we get cos y dy dx. In step 2, we are going to bring the dy dx at one side, no dy dx at one side. Thus, we get here as 2y dy dx minus cos y dy dx is equal to 4 minus 3x squared. In step 2, we take out the factor of dy dx, and thus we get dy dx times with 2y minus cos y is equal to 4 minus 3x squared. And lastly, in step 4, we solve the dy dx and produces dy dx as 4 minus 3x squared divided by 2y minus cos y. We cross multiply it, then we get this one. This is the dy dx. In this example, we want to find the dy dx for x squared cos y is equal to e powers of 2y plus x squared. If you look at here, x squared cos y, it is in the form of product between x squared and cos y, or u and v. Okay, so where the u is x squared and the v is cos y. Alright, so we assume the x squared is u and the v as cos y. Alright, differentiate x squared, we will get 2x, and differentiate v cos y, we get negative sine y dy dx. Remember, when we differentiate the terms in terms of y, we have to multiply it with dy dx. We need to use the product rule since x squared cos y, it is in the terms of multiplication. So we are going to use the formula uv prime plus vu prime for differentiation of x squared cos y. So by substitute the uv, u prime and v prime, thus we get differentiation for x squared cos y would be x squared negative sine y dy dx plus cos y to x. Okay, x squared is the u, v prime is negative sine y dy dx, plus the v is cos y, and the u prime is dy 2x. And it is equal to, okay, we need to differentiate the right side. Okay, it is equal to, differentiate e powers of 2y here. Okay, it is in the form of e powers of fx. When we differentiate e powers of fx, we will get e powers of fx times f prime x. So here we differentiate e powers of 2y. So we get e powers of 2y times 2. And remember, because the function in terms of y, we have to multiply with dy dx. And after that, differentiate x squared, we get 2x. In step 2, we are going to bring the dy dx at one side, no dy dx at one side. So thus we get it as that one, negative x squared sine y dy dx minus 2e 2y dy dx is equal to 2x minus 2x cos y. Then in step 3, we take out the factor for dy dx and thus reduces this one. Dy dx is equal to negative x squared sine y minus 2e 2y is equal to 2x minus 2x cos y. And lastly, in step 4, we are going to solve the dy dx, and thus we get the dy dx as 2x minus 2x cos y divided by x squared sine y minus 2e 2y, or if we simplify it, we can write it in terms of 2x multiply with 1 minus cos y divided by negative bracket x squared sine y plus 2e 2y.
Okay, now let's say we have another example. Okay, 4y is equal to sine xy is equal to 2 ln 3x. We want to find the dy dx of this function. Okay, so now we are going to differentiate it both left and right side. Okay, so we differentiate 4y here. Okay, 4y, if we differentiate, we will get it as 4 dy dx. Alright, okay, minus, okay, differentiate sine xy. Okay, so if you look at here, sine xy, it is in the family of sine fx. Okay, it is in the family of sine fx. Okay, if we still remember, if differentiate this one d, okay, stand for differentiate. So we will get it as cos fx multiply with f prime x. Okay, so there is, if we differentiate that one, okay, so the sine, this is referred to sine fx. Alright, in this case, what is the fx in this case? Okay, fx in this case is, the function is xy. Okay, so it is the differentiation, so we put it as f. Okay, f only. Okay, so the function f, it is equal to xy. Alright, so if we look at here, it is a multiplication between x and y, so you have to use the product rule here. Okay, so the u is the x, okay, the v is the y, and the u prime is equal to 1, and the v prime is equal to 1 dy over dx. Differentiate y we get 1 times dy dx. So therefore the f prime x, okay, f prime will be u v prime plus v u prime. So if we substitute here, we get x dy dx plus v is y times 1. So we get x dy dx plus y. So that is the f prime. Alright. So now we are going to substitute in the differentiation. Alright. So we write back here. Okay, we bring this one here. Calculation. Okay. So we get here. Okay, we write back. Differentiate 4y. We get 4 dy dx. Right. Minus with okay, we got here cos fx times f prime x. Okay, we get cos xy multiply with f prime x. Okay, x dy dx plus y. Alright, so it is actually comes from this one. Okay, the formula comes from this one, and this is the f prime x. Alright, so it is equal to, okay, differentiate 2 ln 3x. Okay, so ln 3x, it is in the family of ln fx. Okay, so if you still remember, differentiate ln fx, we get 1 over fx multiply with f prime x. Alright, so therefore here we get it as 2, okay, differentiate ln 3x, we get 1 over 3x times 3. Alright, so now we are going to expand that one. So we have here, we have 4 dy dx minus x cos xy dy dx is equal to, alright, so this one cancel out, so you get 2 over x, and then we expand that one, we have plus cos plus y cos xy. Alright, we multiply negative cos xy with y, and we bring to the other side, we get that one. Alright, now we factor the dy dx, so we have factored it. We get 4 minus x cos xy divided by 2 over x plus y cos xy. Alright, and after that, we make equal the denominator first. So it is equal to 2 plus xy cos xy divided by x. Alright, so therefore we get the dy dx as cross multiply, we get 2 plus xy cos xy, okay, x multiply with 4 minus x cos xy. So this is the dy dx for this case.